Hi everyone, and welcome to a new episode in the Multiverse video series. Today we're going to continue with our distributed deep learning episodes, and we're going to cover how to do distributed deep learning with Apache Spark, TensorFlow, and R. This is a video that I've been particularly excited about, and it took me a while to get into, so I hope that you enjoy it. Right, actually, before we get started, I think we need to do a quick recap on what barrier execution is. Now, barrier execution is a new feature from Apache Spark that became available around Spark 2.2, I believe, but definitely available in Spark 2.4. And we covered this feature in the past in one of our previous videos, but perhaps it wasn't obvious why this feature is so cool and so interesting. To give you a sense of what a barrier execution is, let me just take you back to this keynote from Reynolds Shin and try to explain why this is interesting and why it makes sense to do deep learning with Apache Spark. So what you can see on the left side of this slide is that basically in the past, Spark was mostly used to perform big data analysis, right? So you would have a big, large data set distributed across multiple computers. And what you would usually do is you would perform things like analyzing with tools like SQL or dplyr, and mostly take this large data set and process it and find analysis using Apache Spark, and then perhaps do some modeling using MLlib, like logistic regressions or XGBoost or whatever. So that's like the primary use case of Spark and the motivation why Spark got created. However, what we're also seeing today is that there's a lot of frameworks that require a cluster of computers for what we call deep learning or AI, right? And a lot of these frameworks like TensorFlow and PyTorch and CNTK require a cluster of computers. And in fact, if you look at our previous video where we presented how to do TensorFlow with R, you will notice that we used multiple computers and we had to manually connect to each of the computers and set up some of the configuration files. And it was doable. It wasn't that hard, but it was definitely tedious because you need to, and we only use 3 computers, right? But you need to basically connect and configure each of these computers. Now, usually what is happening in general is that, basically what's going on these days is that a lot of data scientists are using 2 different clusters. So they have the Spark cluster that maybe they use to retrieve a lot of information from the web, like maybe images, right? And maybe they're crawling Reddit or whatever. And they might use Spark to retrieve all this information, process it and change it to the correct size, like when you're generating thumbnails or whatever, and then once you pre-process the data set, you push it to a cluster or you manually process it on TensorFlow or PyTorch or CNTK. So it's like the workflow is broken. You have to do first your big data pre-processing analysis and whatever, and then you need to use a separate cluster to perform deep learning. So basically barrier execution, which I believe was codenamed Project Hydrogen before, it basically opens up the possibility of using Spark for both big data and also deep learning. And I won't get into too many details, but basically, there's a new execution model in Apache Spark, which rather than Spark over optimizing how tasks get executed, it basically allows us to retain control of the machines that we need to run other frameworks inside Spark and perform deep learning without having to rely on an additional cluster, which is what we're going to take a look at today. Anyway, so hopefully this gives a brief overview of what barrier execution is. If not, just go back and take a look at one of our previous videos. Let's see. So, this covers what Spark, presents as barrier execution. I just want to give a brief reminder of when sparklyr started supporting barrier execution, which was earlier in this year with sparklyr 1.1. So, in order to use barrier execution, you would need sparklyr 1.1. Currently, we have already released sparklyr 1.2. So, it's already 2 versions behind that we added support for barrier. And let's just take a quick look on how we would perform barrier execution. And it's actually quite simple. Basically, what we want to do is we want to connect to Spark, and then we want to use Spark apply with this new parameter called barrier equals true. And basically that tells Spark is like, hey, don't be overly smart, just execute everything at the same time, which is what TensorFlow would need. Now, probably at the time that we presented this blog post, it wasn't very obvious why barrier execution was super interesting. So, but hopefully this video will present why. And, a few things to mention is that to me were confusing when I started using barrier execution is that barrier execution gives you a list of machines and ports that are ready to use and perform custom processing in the cluster. And the port number that we have here, we can take a look at the documentation or the sources, and it basically shows that it's an IPv4 address host port of the executor that the barrier task is running on. So this was a little bit confusing to me, but now it all makes sense. Basically, it's not the port that you want to use, it's the port that the Spark executor is running on. So the only usable thing here that barrier execution gives you, it's really the IP address. It's the IP address of the current machine that is performing kind of like this operation. You still need to figure out the port number that your framework should use. And the other thing worth mentioning is that as you're troubleshooting barrier execution, sorry, not barrier execution, but as you're troubleshooting TensorFlow distributed within Spark, one of the errors that I hit, which was a little bit tricky to diagnose, was could not start gRPC server. Now, gRPC is the technology that TensorFlow uses under the hood to communicate between the different network machines. It stands for Google Remote Procedure Calls, and it's basically a low-level C++ framework that is very efficient and super fast that allows communication between the machines. Anyways, so unfortunately, this particular error is not very descriptive. But if you happen to hit this error, could not start gRPC server, it usually means that you're using a port that is already being used. So, like if you see this error, just think about kind of like reconsider the ports that you're using, and then it should be kind of like obvious to troubleshoot and fix this particular problem. All right, so let's take a look at barrier execution first. So actually, before we get started, there's a few things that you need to install. So you need to install packages. Obviously, you want to install TensorFlow. So that's something that I already performed before this video. And here, let me just do this. And yeah, so you only need to install TensorFlow. You also need to install the remotes packages. If you remember from the previous video, we have to install remotes, install GitHub, and you want to install RStudio Keras because there's a fix that is needed for distributed deep learning. And you also need to install, well, it's actually highly recommended that you also install sparklyr on development version. And the reason is that there was a fix that we had to put in place to make our life easier when using Spark with Keras in distributed processing workloads. So just be aware of this. Now, this particular cluster that I have here is actually EMR cluster running on Amazon AWS. You can use whichever Spark cluster you have or want to get from. If you don't know how to get a Spark cluster, there's a few videos that we have where we explain you step by step how to get a Spark cluster. But just to let you know that we're actually using a proper Spark cluster. I believe with only 3 machines and 8 cores over each machine, but still a proper Spark cluster nonetheless. So let's go ahead and connect first to Spark, and then let's actually go ahead and copy paste just the very simple example that we have here of barrier execution to give us a sense of how this works out. So let's just run this, and we're gonna say that we're gonna use 3 partitions for our particular data set, and we're gonna run Spark apply and just return the address. Actually, let's convert it as character. Right, let's just do this. And hopefully what this should retrieve is basically the IP addresses and ports of each Spark executor task, correct? And again, we're only requesting 3 machines, but we could as well request 100 machines and use 100 CPUs to perform deep learning at scale. All right, so as you can see here, we basically get a list of IP addresses that are ready to be used. Now, if you're trying to figure out why do we have so many, this would be because each of the machines in the cluster is retrieving a list of all the machines that are available to remote connect to. Shouldn't be that complex, but I believe we also explained this on the barrier execution mode video. All right, so now we have our machines. What do we do next? Well, I think what we want to do next is just make sure that the Spark apply works, which we already did. We're just basically saying run something and return OK, assuming that everything is working properly. And then the next thing that we can do is we can say barrier equals true. And again, this is not changing really anything, but fundamentally what is changing is the way that the Spark apply is being executed. And then what we have to do is we have to do a couple of things. We have to say library TensorFlow and library Keras, because we're going to be using them. And we need to define our distributed computing configuration file. Now, if you remember from the previous video, we basically need to tell TensorFlow how to connect to the machines that are running TensorFlow in a distributed fashion. And you do that by saying tfconfig. Now, we do have to make a few changes when running on Spark. On the previous video, we actually hard-coded all the IP addresses and ports, which was quite easy to understand, but also it's quite tedious. So what we're doing here instead is we are removing, first of all, we're removing the port from the IP address, right? We want to remove this port and we want to create our own port. So here what we're doing is we're just starting at port 8020 and then we're adding 1 to each of the port definitions for each of those addresses that we're getting from Spark. And the last thing that we need to consider is we need to specify the index of each particular worker. This is the feature that we are making use of by using sparklyr from GitHub. We're basically saying this new feature in sparklyr adds an identifier for each particular partition in Spark to let you easily map the worker node's address to an index without you having to do a lot of like computation and workarounds. Like you can probably do it with a previous version of Spark, but it would just be annoying to figure out this particular index anyways. And then what we need to do is we need to make sure that TensorFlow is installed on each of the worker nodes, right? Because we have the package installed and sparklyr will distribute your R packages to each of the worker nodes. But we still need to install the runtime because that's something that R is not aware of. So we're going to do that and we're going to say OK after we finish transforming this. And really all we're doing here is just making sure that TensorFlow is properly installed in each of the worker nodes, correct? We'll give it a few seconds, make sure that, yeah, there you go. Now we are sure that TensorFlow is properly installed in each of the worker nodes, which is great. So what do we do next? Well, now we can grab our training code and actually copy paste it to Spark, right? So let's go ahead and do that. But before that, I want to give you a little trick that is really worth understanding. So this is like a little trick that I believe we present also on the Mastering Spark with R book. But basically it's a trick when using Spark Apply. So if you want to troubleshoot the errors that are happening on the R session, one very easy way of doing this is just to add a try-catch block statement and then return the error message in case something happens. And I use this all the time just to make sure that when something is broken, rather than having to go and figure out the worker logs, you can just put a try-catch block and return the error message as long as you're working with character columns. And then you're going to be easily able to identify why the R script is broken. So in this case, nothing should break, but it's like a great way of like making sure that your scripts are usable without losing too much time. All right, so after this, what we want to do is we want to copy paste our script, right? So in this case, we have kind of like a TensorFlow with R script to train the model. And one caveat is you want to transform, if you were previously doing training with a single machine, you want to transform your script to use multiple machines when using distributed training. Again, like if you don't remember or how to do this, or you haven't watched our previous video, just watch our previous video where we go step by step on how to transform a single computer Keras script into a multi-machine Keras script. Just to give you a quick overview, you need to specify the mirror strategy, multi-worker mirror strategy to use multiple computers. It needs to be one of the things on the very top of your script. And then you need to use a scope to define your model and also compile it. That's pretty much it. You also need to consider how you're distributing your data set and which data each worker node is using. But watch the previous video if you want more details on how distributed processing works in TensorFlow and Keras. All right, that's pretty much it. Then we want to train our model, and then we want to basically, once we train our model, we want to just retrieve something meaningful, right? Which in this case, what we're going to return is just the accuracy that is being reported over each step while we're training. So let's give this a shot, and honestly, it should just work and retrieve basically the accuracy of training a distributed deep learning model using Apache Spark, TensorFlow, and R. So again, this is taking time because basically Keras is initializing, is running 3 epochs, I think in this particular case, and then retrieving the accuracy for this particular module. Right, we'll wait a little bit more. Shouldn't take more than a few seconds. We'll see. And if for some reason this doesn't work out, we will also learn how to troubleshoot this. But no, it seems that it worked just fine. And as you can see here, this is basically the accuracy being reported by each worker node. And the accuracy is the same in each worker node since they're training in a distributed fashion. And like they're synchronizing their gradients, so we expect to see the same accuracy. But yeah, pretty much this is what we're getting. All right, so before we wrap up this video, I want to mention a couple interesting things. So the first one is that even though we train a deep learning model distributed, the model still lives in the worker nodes, right? Like we asked TensorFlow and Spark to train our model in a distributed fashion, and that's great. It worked out. We have our accuracy, but the model is still on the worker nodes. So now the question is like, okay, how do I retrieve that model into the driver node? Because maybe you want to, push this model to RStudio Connect or SageMaker or whatever, and do, scoring using the model that you trained, or whatever, right? So you probably want to retrieve the model. So one way of doing it, that's the way that I came up with in this particular video, is you can just say, save the model as an HDF5 file, which is the default format from the Keras models. So what I'm doing here is, I'm just assigning a name, and then I'm just saving the file. So that means that the trained model is now persisted in the current machine, but that's not enough. We also need to retrieve it back. So one easy fix that we can do is we can just serialize this file as a base64 encoded file that we're doing here, and just retrieving it from one of the worker nodes. And again, the model has been trained across all the worker nodes, so we don't need to retrieve the model from each of the worker nodes, right? That's the whole point of distributed training. We want like a single model. So what we can do next is just say, hey, retrieve this model as a base64 encoded string, which is just a binary string in text format, and retrieve it to the driver node. And then if we were to do this, basically, it will retrieve the file into the driver node, which is what I did previously. So here I have like an HDF5 file with 4 megabytes. And then you can just use, again, you can use Keras and say load HDF5 file, and then you can like run scoring using that particular model. Yeah, so that's pretty much it. Honestly, one of the great things about this is that you can basically change the number of computers that you're using, and the model will scale automatically. You don't need to worry about reconfiguring or installing TensorFlow and all these things that you need to do manually if you don't have a cluster framework to help you set up these resources, a little bit, more straightforward than doing those by hand. There's a couple more things that I want to mention before we close this video. In this particular scenario, I wasn't using GPUs. I was just, the only thing I used were CPUs, and the only thing I was doing was training a distributed learning model with multiple GPUs. Yeah, with multiple CPUs. But if you need to use a GPU, you can take a look at the Spark documents. And actually, there's a property here that you need to set when you use GPUs, and that would be Spark executor resource GPU amount equals something. So for instance, in this particular case, suppose that we were to have three computers, each computer with a GPU. What you would want to do is when you connect to Spark, you want to tell Spark, hey, by the way, I want to use 3 GPUs. Please give me 3 GPUs as executors. And then you would get the GPUs, and then when you run Spark apply, each of the instances would be running in one machine. Again, it should be pretty straightforward. I haven't tried myself, but hopefully one of the next videos that I do is to train something interesting. Maybe I'll give it a shot at trying something similar to ImageNet, and for that we're going to need to use GPUs. But if you're ahead of me, just be aware that this property is available for you to use. And last but not least, I'll put a link on the YouTube video to this repo. This repo is basically just kind of like a catch-all place where I'm throwing all the code that I'm using for training distributed deep learning models, either on manual clusters or Spark. So there is a new section somewhere in here for Spark, where you can just, if you want to use the same code that I'm using, you can just copy paste it and, kind of like get you up and running with distributed deep learning in Apache Spark with TensorFlow and R. All right, well, I hope that you enjoyed this video. Thank you so much for watching, and we'll keep you posted with new topics. Thanks again for watching.